All right, so quick review of last time. Last time we talked about rational functions. Raise your hand if you remember what a rational function is. That does not bode well for today's lesson. Frowny face. Brandy, what's a rational function? No making frowny faces. Marissa, help Brandy out. Very good. Fraction with a poly in the top and a poly in the bottom. Ratio of polynomials. Very good. And we talked about some features of those types of functions. First, we learned about how to identify their domain. And we talked about asymptotes and holes. Also known as what? What was that other name for holes? It's a fancy two terms. Removable discontinuities. Very good. So asymptotes and discontinuities. All right. So domain. Who remembers what we did to find the domain? Which x values? Zeros. Very good. Exclude zeros of denominator. Very good. Can't have zeros in the bottom of a fraction. So we use our skills for finding the zeros of polynomials. We figure out where the zeros of the polynomial in the denominator are. Perfect. For vertical asymptotes and holes, who remembers what we did? Starts with an F. First thing we got to do. Factor, yeah. We factored the numerator and the denominator. We reduced the fraction by canceling those common factors. Bless you. And then if it got canceled, it formed a hole. And if it was not canceled, it formed a vertical asymptote. That is not how you spell cancel, Mr. Jolliffe. Horizontal asymptotes. What did we look at to figure out where our horizontal asymptotes were? Who remembers? Numerator. What about the numerator? The degree. Very good. So this one we compare the degree of the numerator and the denominator. Perfect. So I look at the leading terms on the top and bottom. I look at the biggest exponents. If the top is smaller than the bottom, y equals 0. If the top and the bottom have the same degree, it's a ratio of the leading coefficients. If the top is bigger than the bottom by 1, we have to do synthetic division, and we get a slanted asymptote. Good. So those give us a whole lot of features of the graph. There's two more local features we want to talk about, and those are the x-intercepts and y-intercepts. So let's start with y-intercepts. How many y-intercepts should a function have? 1. Very good, because I should not have points stacked on top of each other. Then it's not a function. It fails the vertical line test. So there's one y-intercept for every rational function. And the y-intercept occurs where x equals what? 0. Very good. Very good. So all I have to do to find my y-intercept is find f of 0. That's not so bad. Make the x a 0. See what we get. So let's do some examples. So I have the function x minus 3 over x squared minus 9. I want to find its y-intercept. And I know to find my y-intercept, I'm finding f of 0. Which means everywhere I see an x, I replace it with a 0. 0 minus 3, 0 squared minus 9. What does that give me? Negative 3 over negative 9. And negative divided by negative becomes positive. So I know my answer is going to be positive. 3 over 9 reduces to 1 over 3. Perfect. So my y-intercept is the point x equals 0, y equals 1/3. Perfect. You will notice a pattern. It's a general rule. When we make x 0, we're left with just the constant terms. So our y-intercept is usually a ratio of the constant terms. Not so bad. Try another one. Next one, f of x equals 3 over x. Before I do any math, predictions on where my intercept is going to be? So I heard two answers. I heard 0, and I think that was a do not exist, but I'll check. Am I allowed to do that? D and E. Yeah, it does not exist. D and E. That means I have no y-ints. It's not that it's not a function, but it is that I have a vertical asymptote at 0. So this graph, if I were to sketch it, is doing this. It never touches the y-axis. On the left, it's constantly going down. On the right, it's constantly going up. Yeah. Vertical. You got it? Vertical asymptote right there. And I know there's a vertical asymptote there because I know vertical asymptotes happen at the non-cancelable zeros in the denominator, which would be x equals 0. So that makes sense. I have an asymptote there. I should not have an intercept. Good. Good. One more, because practice is good for us. Oh, that's not what I meant to do. I'll do this. Is that what I meant to do? Why am I having a brain fart? That's fine. Because it's Friday and my brain is exhausted. So f of x equals x squared minus 9x over 2x squared plus 2x. We want to find f of 0. Without having to evaluate, what is f of 0 going to be? Over 0, which is also not defined. Does not exist, right? Doesn't matter what's in the numerator, I can't divide by 0. So this is another one that has no y-intercepts. If it is missing a constant term in either the bottom or in both, you are not going to have a y-intercept. Yeah. If it's just missing a constant term in the top, it's okay to have a y-intercept of 0. It's okay to pass through the origin. I cannot have 0 in the bottom. So if the bottom's 0, there's no y-intercept. The y-axis is an asymptote. Meaning I should know ahead of time that I won't have any y-intercepts, because one of the first things we did was we found the domain and we figured out where our vertical asymptotes are. If y equals 0 is a vertical asymptote, I don't have to look for y-intercepts because I know they won't be there. I don't cross it. So when we do this from start to finish, we're doing them in order. Make sure you're making connections between the steps, yeah? Okay, last thing. Focus, children, focus. X-intercepts. Where do x-intercepts happen? Mm-hmm. Exactly, where the function is 0, has no height. Perfect. I know that I don't get 0 as an answer if 0 happens in the bottom of the fraction. So I'm looking here at zeros of the numerator, but I want the zeros of the numerator of the reduced fraction. Which I should already have because I have found my vertical asymptotes and holes, meaning I've already factored the top and bottom. I've already canceled the common factors. That's why we do intercepts last. Let's do some examples. All right, Julie. If I want to find the zeros of the reduced numerator, I need to reduce my fraction. So what should I do to it first? Starts with an F. Factor, very good. Factor top and bottom. Top is factored. X minus 1. How do I factor the denominator? Suggestions? Very good, Brandy. Play the x game with the denominator. Factors of positive 2 that add to negative 3. What would those be? Very good, Aubrey. Negative 2, negative 1. Those multiply to positive 2, add to negative 3. So x minus 2, x minus 1. So I have zeros in the denominator at 2 and 1, so asymptotes and wholes there. When I reduce, x minus 1s are going to cancel. What am I left with in the numerator? Yeah, we cancel things that are the same. I see something, and then x minus 2. Anything divided by itself is, right? So the question, I'm looking for x-intercepts. What makes that numerator 0? Ooh. Can the numerator ever be 0? No. 1 is not equal to 0. I don't have any x's. Deeper question for you. Why does that make sense in terms of that function? Where does that guy have a horizontal asymptote? That would be good. 0, y equals 0. That has a horizontal asymptote at the x-axis because the bottom is smaller than the top when you look at those degrees. If he's got a horizontal asymptote at the x-axis, he's not going to have any x-intercepts. Yeah, that makes sense in terms of what we see with the asymptotes. That's why we start with the asymptotes. Let's try another one. Yes, it's 0. Come on, pen. There we go. Making problems up in your head is hard, and I'm tired. I want to find the x-intercepts. What should I do first? Starts with an F. Factor. Very good. Top is already factored because I'm tired, because it's Friday. What does the bottom factor into? Very good. Very good. That's a difference of squares pattern. We've seen that before. When I reduce, x plus 5 on top, x plus 5 on bottom go away. I have a removable discontinuity, a hole, at x equals negative 5. I have a vertical asymptote at x equals positive 5. Where do I have an x-intercepts? Gabe, how do I find my x-intercept? Where y equals 0. And specifically, the y equals 0 when top is 0 or bottom is 0? Numerator or denominator? Which is going to make the whole fraction 0? The numerator. I can't have zeros in the bottom. Those are giving me asymptotes. Good. So I'm looking for where the numerator is 0. Numerator 0 makes whole fraction 0. Numerator 0 makes whole fraction 0. X minus 2 equals 0 means x equals 2. It's going to cross at x equals 2. Vertical asymptote at 5. Intercept at 2. Try another one. You seem to be a little goofy today. All right, Jordan, what do I do first? I want to find my x-intercepts. What should I do first? Starts with an F. Factor. Factor top and bottom. Very good. Starting with the numerator, what can I pull out that they all have in common? They have an x in common, which is going to leave me with x squared plus 3x plus 2. What are the factors of x squared plus 3x plus 2? 2 and 1. Very good. X plus 1, x plus 2. Perfect. Denominator, x squared plus 2x plus 1. What are the factors of x squared plus 2x plus 1? 1 and 1. Very good. Some stuff cancels. X plus 1 divided by x plus 1 cancels. I am left with x times x plus 2 over x plus 1. I want to know where my x-intercepts are. Jade, how do I figure out where my x-intercepts are? Set the numerator equal to 0. Very good. So x times x plus 2 equals 0 tells me that x is 0 or x plus 2 is 0. Top one's already solved. X plus 2 equals 0 means x equals -2. And I want to check that that makes sense because I shouldn't usually have 2 intercepts. So I think about the reciprocal function. Normally the reciprocal function does this. I would expect only 1 crossing if I shifted that graph up or down. I'm seeing 2. The question is why? So we're going to compare those leading terms. What do the horizontal asymptotes of this guy look like? I'll give you a minute, check your notes, check with your neighbor. What do the horizontal asymptotes of this guy look like? You don't have to give me an exact answer, just big idea. What do they look like? All right, Melanie. What'd your team come up with? Slanted. How did you know? I agree. How did you know? Very good. That is exactly right. We know we get slanted asymptotes when the numerator is bigger than the denominator by 1 degree. We have power 3 on top, power 2 on bottom. Top is bigger by 1. So I know I'm going to get a slanted, which means I'm getting those U shapes that can cross twice. Good. Very good. So what I'm seeing is that my intercepts, x and y intercepts, I'm finding them the same way I did before, x equals 0, y equals 0, but my answers should be consistent about where I know my asymptotes are. That information should match. When I see you next week, we're going to practice graphing using all of this information plus the end behavior of the functions. Today, what I'd like you to do is, if you did not finish quiz 5, I want you to get your Chromebook out. If you did finish quiz 5, I want you to get a pencil out, and I'm going to give you some practice problems with finding those vertical asymptotes. This is not a homework assignment. You're going to turn in what you have at the end of class if you got very far. If you didn't, take it home, and if you've got time, work on it and drop it in my box on Monday, whatever you had a chance to work on. It's not meant to be punitive. It's just meant to give you some practice. Everything on here is factorable, so don't overthink. Look for common factors and then play X game. I'm going to unlock the quiz in just a second. You've got the rest of the period to work on your quiz or work on your worksheet. Yes, Melanie. You're going to do the worksheet after you finish the quiz. It should not take the rest of the period to finish the quiz. Good question.